work today. So in front of you, you've got a blank paper. Okay, there's not any problems on there. In order for you to do anything today, you've got to look up here on the board. Okay, so for each one of these problems we're doing today, you're using these graphs. Y equals the square root of x plus 1, that's the red line. We've got y equals 3, that's this blue line. And then we've also are going to use the y-axis and x-axis and other things. But those are the two main lines we're going to use every time. Y equals 3 and y equals square root of x plus 1. Based on the problem, you are going to all you're doing is showing how to set that thing up. Okay, so you don't need to use any calculator or anything else. So for this first one, I also included the line x equals 7. Your job is to find the area, not the volume, but find the area of this shaded region. Okay, so in your group, you are going to work through that and set it up. When you think you are correct, you're going to raise your hand. I'm going to come around and check you. And once I've checked everybody, then we will go over it together and move from there. Everybody understand how this is going to work? Go. We are finding area. Okay, so when we set this thing up, we're using integrals. Jake, why do you need two separate integrals on this one and not just one? The top line changes. It is not the same line on top and bottom the whole time. Technically, you could make this a dy problem if you wanted to. You don't want to. Make it dx. Okay, so top to bottom, top to bottom, top to bottom until there. Jake's saying it is the same line on top and bottom. So, Jake, is this a dx or dy? It is a dx problem because he is going top to bottom as we find area. Okay, what are my bounds going to be? 0 to 4. And what's your top line going to be? Square root of x plus 1 minus the bottom line, which is just 0. That's it. That's our first integral. That will find him the stuff in pink there. Make sure you put dx at the end. If you don't have dx, then you're really integrating twice, and you don't want that. You've got to split up that integral from there to there, dx. So obviously we don't need that minus 0. You could just write square root of x plus 1. Everybody go on the first one. Brianna, what about our second integral here? What does that look like? 4 to 7. Good. So from 4 to 7 now, she's saying we're changing what's the new top and bottom line. It's the same top and bottom line throughout that interval. What's your top line? 3 minus your bottom line. So just 3 and then dx or dy? Dx, because we're working perpendicular to the x-axis. Questions there? There's the first one, hopefully not too bad because area is pretty easy. Let's go to the second one. Okay, you're looking at this shape right here. So look at the shaded region up there. This is still the square root of x plus 1. This is still y equals 3. You are finding the volume of the solid when you rotate about the line y equals 3. A reminder that if you are using the line y equals 3, when you write your radius, you are going to use the line y equals 3. As we look at this problem, we're going about the line y equals 3. So show me with your arm, what does going about the line y equals 3 look like? Spinning vertically like a pinwheel. Okay, and so as we set this thing up, is it a dx or dy problem? Dx, because of the way you're spinning, because you're rotating this way. Okay, we're spinning that direction. It is a dx problem. So Harrison, from when to when are my bounds going to be? 0 to 4. It's an x problem, so he is going from 0 until 4. That's when these things stopped intersecting. Disk or washer here? Yes. It is a disk problem because my shaded area is flush up against the line that I'm rotating around. I'm right up against it. So if it's a disk, the first thing you should do right here is pi r squared, because to find volume, you integrate area. Set it up like that. Okay, you might know how to do it, but writing that down is going to let you screw this up less. Okay, so I only need one radius. I need the big line and the little line. Okay, so as I set this thing up, sorry, crashed on me. Big line. What's the top line going to be here, Augie? 3, because if we're rotating around the line y equals 3, we're going to include 3 in our answer. So it's 3 minus the bottom line. What's the bottom line going to be? Square root of x plus 1. But if he wrote it like that, it'd be wrong. He has to parentheses. There's my answer. That's going to get me the setup for the second one. Questions there? Number 3 here is just same shape, y-axis. You're taking it, you're rotating it around. Set it up. All right, we're rotating this thing about the y-axis, so it's going like this. So when I set this thing up, Logan, is this a dx or a dy problem? It is a dy problem because we are rotating. I made you show me. We're rotating this way. Okay, you are rotating from right to left, right to left, right to left. Victoria, what are my bounds going to be? 1 to 3. It's a dy problem, so she wants the y value. She's going from 1 to 3. Then we are looking at this. Is this a disk or a washer? Disk, because I'm flush up against the line. Pi r squared. All I need to know is my radius. I'm going to include in that line whatever line I rotated around. Well, I rotated around the line x equals 0, the y-axis. So it's going to be something with 0 involved. I want to go right to left. So the right line is this guy. Why can't I just write square root of x plus 1 right there? It's a dy problem. It's a dy problem. A lot of you didn't have that correct. So I need to solve for y. So I'm going to subtract 1. And then I'm going to square it. And so it is y minus 1 squared, or y minus 1 to the 4th power. Questions on that one? Now let's turn it up a little bit. Not too bad so far. Now you're taking this shape, including the line x equals 4, and you are rotating it around the y-axis. See what you can do? We set this problem up. We have discussed that this is going to be a both question, where we're going to need 2 separate integrals. Because when I rotate this around, from here to here, it's a good old disk problem. When we go up the line, it's going to become a washer problem. Again, it's because it's flush up against the line here, and here there is a space in between. So my first integral, okay, I'm rotating about the y-axis, so this is a dy problem. Luke, what are my bounds going to be for my first integral? 0 to 1, because from 0 to 1, I'm flush up against the line. Okay, what shape are you going to have, a disk or washer? A disk, so it is pi r squared. What's your radius going to be? 4, because it's just this line right here revolved around. It's just 4. So it's 4 squared, or just 16. Cool, that's my first one, plus my second one. When I'm rotating the second one, it's a washer problem. Okay, Simon, from when to when am I doing the second integral from? 1 to 3, because from 1 until 3, there's a gap. It's a washer. So it's pi. How do you find washer? What's my formula going to look like? Big R squared minus little r squared dy. Make sure you're squaring each radius individually, because otherwise you'll start putting them together. So, Kate, what's my big radius going to go from? 4. That's the outside line. That's the right line, because we're rotating around the dy. So it's 4 minus 0, because the big one's going to go to 4 to 0. That's the big line. So it's just 4 squared. Minus my other one. What's the other one going to include? That's this line right here. She knows that this is y minus 1 squared. She got it in terms of y. And that one's minus 0 as well, because we're rotating around the line y minus 1. So y minus 1 squared, or y minus 1 to the 4th. That's super ugly looking. Questions on that one? Again, in your brain, think, if I'm revolving around that line, I got to use it. So again, we revolved around the y-axis, so we are going to use 0 in all of these. 2 more, okay? Number 5, we are taking that shape right there, and you're revolving it around the line. Y equals 4. Revolve that shape around y equals 4. See what you get. We're rotating around the line y equals 4. Show me with your finger which way you're revolving. We're going this way. Boom, boom, boom. So that makes it a dx problem, because you're rotating in the same way as the disk. As the x-axis. Is it a disk or a washer problem? Washer. We are integrating this thing from 0 to 4, because we're on the x-axis. It's a washer problem. So pi r squared minus r squared dx. I'm rotating about the line y equals 4, so both of these better have a 4 in them. 4 is the top line, so we're going from 4 to the bottom line. So it's 4 minus the bottom line, which is the square root of x plus 1. Minus the other one, it's 4, because that's the top line, minus the middle line. The middle line here is 3, or just 1 squared, or just 1. Questions on number 5? One more. You're finding the shape, the volume, where cross sections perpendicular to the x-axis are going to be right isosceles triangles with legs in the plane. Right isosceles triangles with legs in the plane. You're finding the volume. See what you can do. Here we go. We are cross sections perpendicular to the x-axis. Show me with your arm, what does perpendicular to the x-axis look like? So draw that on your paper. Perpendicular to the x-axis looks like this. Draw a few of them and then realize, okay, I'm drawing isosceles right triangles. So take one of them and make it into an isosceles right triangle, or that. There's my setup. So in other words, you are going to stack these triangles starting from 0 and going until 4. If we're going from 0 to 4, is this dx or dy? This is a dx problem. Okay? We're integrating from 0 to 4. It is, to find volume, we integrate area. We are doing the area of a right isosceles triangle. So what is the formula for a right isosceles triangle? 1/2 base times height. It's isosceles, so it's base squared. So we just need to know, when are we drawing these bases from? Well, the base of the triangles go from the top line to the bottom. Or in this case, we are going from 3 minus the bottom, which is the square root of x plus 1. Make sure you got that in parentheses. That is my setup. Questions on something we did? We can look at that and be like, oh yeah, I completely forgot how to do it. It's not any different than anything else. It's just saying, hey, what's my shape? My shape changed a little bit, so I got to go from there. Looking at this with your neighbor. Okay, here are the different things that we covered today. You are going to have your last test of the year besides your final on Thursday. Okay, which thing is still making you stumble? Look at those different things here. Talk with your neighbor for a second and decide which one of these concepts are you not the best at. Talk for a second with each other. Sorry, it died on me again.